Hello, my little mathematicians. Today we are going to review some multiplying fractions with whole numbers and multiplying fractions with fractions. And we're going to introduce multiplying fractions with mixed numbers. Okay, so first off, to refresh your memories, when multiplying a fraction with a fraction, okay, you multiply the numerators. So 2 times 5 is 10. And then you also multiply across with the denominators. 3 times 6 is 18. And then if it wants it in simplest form, you would reduce this. So you take 10 over 18 and see what could go into both. Oh, 2 can. So 10 divided by 2 is 5, and 18 divided by 2 is 9. But in order to make you not have to reduce at the end, sometimes you can simplify first by cross canceling. So you look at the numbers of diagonally across from each other, 2 and 6. Can anything go into them? Yeah, 2 can. And 2 divided by 2 is 1. And 6 divided by 2 is 3. So now, instead of 3 times 6, it's 3 times 3, which is 9. And instead of 2 times 5, it's 1 times 5, which is 5. So you jump to the answer of 5/9 faster than if you had multiplied across and then reduced later. Okay, so let's go ahead and try some of those. Okay, so the first one, okay, you could multiply across and get 16 over 40, right? But then let's say it's multiple choice and that's not an option. I'd have to try to reduce it. Okay, so you'd be like, okay, I guess 4 can go into both. And 16 divided by 4 is 4. And 40 divided by 4 is 10. Oh, look at that. They're both even, so I'm not done. Let's divide by 2. Okay, 4 divided by 2 is 2, and 10 divided by 2 is 5. And then most likely, if it was multiple choice, like that would be your fully simplified answer. Yes, 16 over 40 or 4 over 10 or even 8 over 20 are still good, but this is fully simplified. Okay, and to get there faster, what would have made it easier is if I would have reduced or cross canceled at the beginning. So what can go into both 4 and 8? 4 can. 8 divided by 4 is 2, and 4 divided by 4 is 1. Nothing can cross cancel here. So now when I multiply across, I have 4 times 1, which is 4, and 2 times 5, which is 10. And then you're like, okay, those are both even, so I can reduce it. 4 divided by 2 is 2, and 10 divided by 2 is 5. See that I still got the same answer, but in less steps because I cross-canceled. Okay, why don't you try some of these and try to get them in fully simplified version, okay? Pause the video, try it yourself, and then come back and join us. Okay, I'm going to start with cross-canceling. I think that's easier. So 9 divided by 3 and 3 divided by 3. Well, the 3 divided by 3 becomes 1, and the 9 divided by 3 becomes 3. So on top, you have 1 times 1, which is 1, and 3 times 5, which is 15. Okay, now those of you that just multiplied across, you got 3 over 45. Well, 3 over 45 can still reduce to 1/15. Okay, our next one. Do you see anything that can go into 5 and 10? Yeah, 5 can. Okay, and then 5 divided by 5 is 1, and 10 divided by 5 is 2. Do you see anything that can go into 6 and 9? 3 can. 9 divided by 3 is 3, and 6 divided by 3 is 2. Now when you multiply across, you have 1 times 3, which is 3, and 2 times 2, which is 4. I just think that's easier than if I had multiplied across. I would have gotten 5 times 9 is 45, and 6 times 10 is 60. And then you would have been like, okay, well, they end in 5 or 0, so I know 5 can go in. 45 divided by 5 is 9. 60 divided by 5 is 12. And then you'd see, okay, 2 can't go in, but 3 can. 3 divided by 3, or 9 divided by 3 is 3, and 12 divided by 3 is 4. So see, I still get the same answer. I just got there faster with cross-canceling. Okay, and then finally, for this one, if you multiplied across, you'd get 2 over 18, and then you'd see, oh, I can reduce that by 2. 2 divided by 2 is 1. 18 divided by 2 is 9. And that's as far as we can go. That's fully simplified. But had you cross-canceled by 2, 2 divided by 2 is 1. 2 divided by 2 is 1. 1 times 1 is 1 on top. And 9 times 1 is 9 on the bottom. So see how I would have gotten to the final answer in just one step if I had cross-canceled first. Okay, so that's how we multiply a fraction with a fraction. All right, when we're doing a whole number and a fraction, we first change the whole number to a fraction by placing it over 1. Okay, so you can see right here, the whole number is 4, so they just put 4 over 1. Now it's a fraction and a fraction. Okay, then you do just like before. You multiply the numerators and you multiply the denominators and you simplify if you can. Okay, and once you get to this step, you could cross cancel if you want. Okay, so let's go ahead and give this a try. Okay, so put the 10 over 1 because 10 over 1 is saying 10 divided by 1, which is 10. So 10 over 1 is still 10. But now I can do my fractions. So 3 times 10 is 30, and 5 times 1 is 5. Well, 30 over 5 is 6 because that's saying 30 divided by 5. If you wanted to do cross-canceling instead, you would see 5 could go into both. 5 divided by 5 is 1. 10 divided by 5 is 2. 3 times 2 is 6. Over 1 times 1 is 1. And that's just 6. Okay, let's try this one. You have 5 times 2 is 10. And 12 times 1 is 12. Those are both even, so I can reduce. 10 divided by 2 is 5. And 12 divided by 2 is 6. So you get 5, 6 as your final answer. Had you done it by cross-canceling, okay, you would see what can go into 2 and 12? 2 can. 12 divided by 2 is 6. And 2 divided by 2 is 1. So now when you multiply across, you have 5 times 1, which is 5, and 6 times 1, which is 6. So you still got the same answer. All right. If you haven't tried any yourself, please try these next two. Pause the video, try them, and then come back and join us. Okay. So if you had 1/8 times 8 over 1, okay, you could have multiplied across 1 times 8 is 8, and 8 times 1 is 8. 8 divided by 8 is 1. Or if you cross-canceled, 8 divided by 8 is 1. That 8 divided by 8 is 1. So you have 1 times 1, 1 times 1, and 1 over 1 is just 1. Okay, and finally, you have 14 times 1 is 14. 1 times 7 is 7. Okay, what can go into both? 7 can. 14 divided by 7 is 2. And 7 divided by 7 is 1. Okay, now I want to point out something with this problem. I strongly recommend that you show what you're reducing by, because do you know how many times people do this part in their head and they immediately see, oh, 7 can go into both. So 14 divided by 7 is 2. And because they knew that answer so quickly, then they see 2 in their mind and they're like, oh, so then 14 divided by 2 is 7. And they put a 7 there. It's like they do the same thing twice and then they get their final answer as 7. Okay. If you show this, you're less likely to put a 7 here. You're more likely to put the correct answer of 2. Also, another reason that it's good to do it this way is because what if your answer, like the answer I got was this? Do you know how many times people put, oh, the answer's 2? Is this reduce to 2? Does this reduce to 2? No, it does not. Because if you show what you're dividing by, you would see, oh, it's 7 divided by 7 is 1, and 14 divided by 7 is 2. So this actually reduces to 1/2. This one reduces to 2, but this one reduces to 1/2. So this is why I so strongly recommend that you always show what you're reducing by, okay? Because this and this both happen often, okay? Now, again, this is not this problem. It's just a similar type of problem. Sometimes you end with 14 over 7, and sometimes you end with 7 over 14. 7 over 14 reduces to 1/2. 14 over 7 reduces to 2. Okay. Sorry, I just had to throw that little side note in because I see that mistake all the time. And I don't want that to happen to you. Okay, last thing. When we're multiplying a fraction and a mixed number, or two mixed numbers, or a mixed number and a whole number, okay, we want to change any mixed numbers to improper fractions. So how we do that is we take the denominator and we multiply it with the whole number, and then we add the numerator. So this one would be 3 times 1, which is 3, plus 2, which is 5. So your numerator, again, you get by going this times this plus that. And then your denominator stays the same. Okay, so we're going to change any mixed numbers to improper fractions. And that's how you do it. And then you'll have a fraction times a fraction. And we do what we've been doing all along. Okay, so let's go ahead and give some of these a try. So this is already a fraction, but this one I need to change to an improper fraction. So I keep the denominator the same, but to get my numerator, I'm going to multiply these and add that. So 2 times 3 is 6, plus 1 is 7. Okay, now can these cross cancel? No. Can these cross cancel? No. So then you multiply across. 1 times 7 is 7, and 5 times 2 is 10. Can you reduce that? No. Is it improper? No. So you're done. Okay, let's try this one. This is a mixed number, so let's change it to an improper. 4 times 1 is 4, plus 1 is 5. This is also an improper, so let's change it to a mixed number. Okay, that stays a 3, and 3 times 2 is 6. 6 plus 2 is 8. Can these cross cancel? No. Can the 4 and 8 cross cancel? Yes. By what? 2, but can you think of something bigger? Yes, a 4. 8 divided by 4 is 2. 4 divided by 4 is 1. Now when you multiply across, you have 5 times 2, which is 10, and 1 times 3, which is 3. That's an improper fraction, so let's change it to a mixed number by taking the top and dividing by the bottom. 3 goes into 10 3 times. 3 times 3 is 9. Subtract that, you get 1. You should always have a remainder be less than what you're dividing by. Then you put your remainder over what you divided by. So 3 and 1/3 is equivalent to 10 over 3, because 3 went into 10 3 times, and you had a remainder of 1. Okay, again, if you haven't tried any of these yourself yet, pause it, try it, and then come back and join us. Okay, so you try these last two. All right, you unpaused it, you're back with us. When you change this to a improper fraction, you did 8 times 2 is 16, and 16 plus 5 is 21. Then this is just 2 sevenths. Can you cross cancel 2 and 8? Yes, you can, by 2. 8 divided by 2 is 4, and 2 divided by 2 is 1. Can you cross cancel anything here? Yeah, by 7. 21 divided by 7 is 3, and 7 divided by 7 is 1. Then multiply across. 3 times 1 is 3, and 4 times 1 is 4. So you get 3/4 for your final answer. Okay, if you just multiplied across, you would have had 42 over 56. That's still equivalent to 3/4. But then if you wanted its simplest form, you'd reduce it down to 3/4. Okay, our last one. If we were to change this to an improper, it starts with a denominator of 4, and then our numerator is 4 times 4 is 16, plus 3 is 19. Times, to make the whole number a fraction, you just put it over 1. Can 1 and 19 cross cancel? No. Can the 2 and 4 cross cancel? Yes, by 2. Well, 4 divided by 2 is 2, and 2 divided by 2 is 1. So then when you multiply across, you have 19 times 1, which is 19, and 2 times 1, which is 2. Now, that's improper, so to change it to a mixed number, I'm going to do the top divided by the bottom. So 2 goes into 19 9 times, and 9 times 2 is 18, and when you subtract that, you get a remainder of 1. So 9 and 1/2 is the same thing as 19 over 2. If you got all those correct, congratulations, my little mathematicians. You now know how to multiply all different types of ways that fractions can show up.